This video summarizes a new report by Massenkoff and McCrory from Anthropic, published in March 2026. The report introduces a novel way to measure how AI is actually affecting jobs, going beyond theoretical predictions to look at real-world usage data. Let's walk through the key findings. Why do we need a new measure? Because past attempts to predict job displacement have a poor track record. A prominent study identified a quarter of U.S. jobs as vulnerable to offshoring, but most of those jobs actually grew over the following decade. Government occupational growth forecasts have added little predictive value beyond simple trend extrapolation. Even in hindsight, the employment effects of industrial robots and the China trade shock remain contested. The authors argue we need a framework that can detect disruption early, before it becomes obvious in aggregate unemployment data. The key innovation is a new measure called observed exposure. Most existing measures focus on what's theoretically possible. Could an AI do this task? But there's a huge gap between capability and deployment. Observed exposure bridges this gap by combining theoretical capability scores with actual real-world usage data from the Anthropic Economic Index. It weights fully automated uses more heavily than augmentative ones, and focuses specifically on work-related applications. The measure operates at the task level and is then aggregated to occupations weighted by the fraction of time workers spend on each task. The measure draws on three data sources. First, the ONET database, which lists the tasks associated with about 800 unique occupations in the U.S. Second, actual usage data from the Anthropic Economic Index, showing how Claude is really being used in professional settings. Third, the theoretical exposure ratings from Aloundou and colleagues, which score each task on whether an LLM could speed it up by at least half. A beta of 1 means a task is fully feasible for an LLM alone, and 0.5 means it needs additional tools. An important finding: 68% of real Claude usage falls on tasks rated as fully feasible, confirming strong alignment between theory and practice. A striking finding is the massive gap between what AI could theoretically do and what it's actually doing. Take computer and math occupations. Theoretical capability covers 94% of their tasks, but actual observed coverage from Claude usage is only 33%. Office and administrative roles show a similar pattern at 90% theoretical. At the bottom end, 30% of all workers have zero observed AI coverage, because their tasks appear too infrequently in the usage data. This group includes cooks, motorcycle mechanics, lifeguards, bartenders, and dishwashers. Jobs that remain firmly beyond AI's reach. Here are the 10 most exposed occupations under this measure. Computer programmers top the list at 74.5% observed exposure, consistent with the well-documented heavy use of AI for coding. Customer service representatives are second at 70%, driven by increasing first-party API traffic handling customer interactions. Data entry keyers come third at 67%. The list is dominated by information processing roles, medical records, market research, financial analysis, and IT support. These are all jobs where the core tasks involve reading, writing, analyzing, or summarizing information. Exactly what LLMs excel at. How does observed exposure relate to future job growth? The Bureau of Labor Statistics projects employment changes through 2034. Jobs with higher observed AI exposure tend to have somewhat weaker growth projections. For every 10 percentage point increase in coverage, the projected growth drops by about 0.6 percentage points. However, the relationship is slight, with an R-squared of only 0.027. Notably, software developers are still projected to grow despite high exposure, while customer service representatives face a projected decline of about 3%. Interestingly, there's no such correlation when using the Aloundou theoretical measure alone, suggesting that real-world usage data adds genuine predictive value. Who are the workers most exposed to AI? The demographic profile is striking. Compared to workers with zero exposure, those in the top quartile are 16 percentage points more likely to be female, 11 percentage points more likely to be white, and almost twice as likely to be Asian. They earn 47% more on average, about $33 per hour versus $22. And they are nearly 4 times more likely to hold a graduate degree. They are also less unionized. This is a different profile from past technological disruptions, which typically hit lower-skilled, lower-paid workers hardest. What about actual unemployment? This is the reassuring finding. Using a difference in differences framework comparing the most exposed workers to those with zero exposure, the authors find no systematic increase in unemployment since ChatGPT's release. The estimated effect is plus 0.2 percentage points, with a standard error of 0.19, statistically indistinguishable from zero. The framework is sensitive enough to detect a 1 percentage point differential increase, so if a major displacement were occurring, it would likely show up. During COVID, it was actually the less exposed workers who suffered more, because they were more likely to hold in-person jobs. But there is one concerning signal. Hiring of young workers aged 22 to 25 appears to have slowed in AI-exposed occupations. The job-finding rate in exposed occupations has dropped by about 14% compared to 2022 levels, while job finding in unexposed occupations has remained stable. This is barely statistically significant, and there is no such decrease for workers older than 25. The pattern is consistent with findings from Brynjolfsson and colleagues, who report a 6 to 16% fall in employment among workers aged 22 to 25 in exposed occupations. Importantly, this appears to be a slowdown in hiring rather than an increase in layoffs or separations. Let me summarize the key takeaways. First, AI has not caused mass unemployment so far. The difference in differences estimates are small and statistically insignificant. Second, there are early warning signs. Hiring of young workers into exposed occupations appears to be slowing, even if overall unemployment hasn't risen. Third, observed exposure, which combines theoretical capability with real usage data, adds genuine predictive value that theoretical measures alone do not provide. Fourth, this framework is explicitly designed to be updated as new data emerges, helping detect disruption before it becomes obvious. The occupation-level data is publicly available on Hugging Face. For more research summaries like this, visit fcastellaneta.com.